Have you ever wondered what quantum jumping is? Let's take a step back to explore the world of quantum physics, the cradle from which this intriguing concept arises. Quantum physics, also known as quantum mechanics, is a fundamental theory in physics that offers a description of the physical properties of nature at the scale of atoms and subatomic particles. Now you might be thinking, atoms, subatomic particles, isn't that stuff too tiny to matter? Well, not quite. In fact, these minute particles play a massive role in the universe's grand scheme, influencing everything from the light we perceive to the solidity of the objects around us. You see, quantum physics is like a backstage pass to the universe's greatest show, revealing the hidden mechanisms that govern the cosmos. It's a bit like peeling back the curtain on a magic trick, allowing us to glimpse the intricate and often baffling workings beneath the surface. Consider light, for instance. At its core, light is made up of particles called photons, which behave both as particles and waves, a phenomenon known as wave-particle duality. Picture a crowd doing a wave at a sports event. Then imagine each person in that wave as a single photon. Each photon is part of the wave, yet also an individual, capable of moving independently. This duality is just one of the many paradoxes that make quantum physics so fascinating and sometimes so confounding. It's a world where particles can exist in multiple places at the same time, where they can tunnel through barriers like a ghost through a wall, and where measuring a particle can change its state. So why does all of this matter? Because understanding quantum physics is the key to understanding our universe at its most fundamental level. It's the first step in comprehending concepts like quantum jumping, which we'll delve into in the next scenes. Quantum physics is a fascinating field, and one of its most intriguing concepts is quantum jumping. So, buckle up as we journey into the quantum realm, where the bizarre is the norm and reality is far stranger than fiction. So, what exactly is quantum jumping? Let's dive right into it. Quantum jumping, in its most fundamental sense, is the transition between quantum states. Picture a particle that exists in a state of superposition. This means it can be in multiple states at once, thanks to the wonders of quantum mechanics. Now, this particle doesn't just stay in one state forever. It has the ability to transition, or jump, between these states. This is what we refer to as quantum jumping. It's like an actor shifting between roles, seamlessly transitioning from one character to another. Now you might be wondering, how does this transition happen? Well, it's not as straightforward as flipping a switch. Instead, it's a probabilistic process. In the quantum world, things are a bit fuzzy. We can't know for certain when and how these jumps will occur, but we can calculate the probabilities of different outcomes, which is a cornerstone of quantum mechanics. One of the most common examples of quantum jumping is seen within an atom. Electrons, the tiny particles that orbit the nucleus of an atom, don't just stay at one energy level, they jump from one energy level to another. When an electron absorbs energy, it jumps to a higher energy level, and when it emits energy, it drops to a lower energy level. This is quantum jumping in action. But it's not just electrons. Quantum jumping is a fundamental aspect of the quantum world, observed in various particles and phenomena. It's like the quantum version of a ballet dance, with particles gracefully jumping between states, each jump choreographed by the laws of quantum mechanics. So, to wrap things up, quantum jumping is about an entity's ability to exist in multiple states at once and jump between these states. It's a dance of particles, a ballet of transitions that is integral to the beautiful, mysterious world of quantum physics. It's a concept that challenges our understanding of reality and invites us to look deeper into the strange, fascinating realm of the quantum world. In simpler terms, quantum jumping is about an entity's ability to exist in multiple states at once and jump between these states. But how does quantum jumping play out in our everyday lives? It's a question that often stumps even the most ardent science enthusiasts. Quantum jumping, despite sounding like a concept straight out of a science fiction novel, has profound implications for our day-to-day life. Imagine you're in a room with two doors and you decide to walk through the one on the right. In the realm of quantum physics, an alternate version of you also walks through the left door. This is a simplistic representation of quantum jumping, but how does this concept translate into our daily lives? The answer to that lies in the technology we use every day. Yes, the very screens you're using to watch this video are powered by principles of quantum physics. Let's delve a little deeper. Take semiconductors, for instance. They are the foundation of modern electronics. Semiconductors are materials that have properties between conductors and insulators. Their behavior can be tweaked by adding impurities in a process called doping. The electrons in these doped semiconductors can quantum jump from a lower energy state to a higher one, leading to the flow of current. This flow is what powers our computers, our phones, our televisions, essentially our digital world. Lasers, another marvel of modern technology, also owe their existence to quantum jumping. In a laser, atoms are excited to a higher energy state. When these atoms return to their normal state, they emit photons. These photons, all in sync with each other, produce a concentrated beam of light, the laser. From the device you're using right now to watch this video, to the supermarket scanner, the long-distance communication systems, and even the medical equipment that helps save lives, quantum jumping is everywhere. So, quantum jumping isn't merely an abstract idea, it's a phenomenon that powers the technology we use every day. Now, let's delve a little deeper into the realm of quantum theory. Quantum jumping, as we've been exploring, is a fascinating concept, but it's also a key that unlocks a much larger, even more mind-boggling theory, the multiverse. Buckle up, because we're about to journey into the world of parallel universes and multiple realities. Let's take a step back to quantum jumping. This theory suggests that particles can exist in multiple states at once and jump between these states. But where do these states exist? The answer could be in different universes. Yes, you heard it right. Each state that a particle can potentially exist in might be happening right now, just not in our universe, but in a parallel one. This is where the multiverse theory comes into play. The multiverse theory proposes that there isn't just one universe, but an infinite number of universes, all existing side by side. These universes are like bubbles in a cosmic foam, each with its own laws of physics, its own history, and perhaps even its own dimensions. So how does quantum jumping fit into this? Well, each jump that a particle makes could be a transition from one universe to another. When a particle jumps to a different state, it might be moving to an entirely different universe where that state is the norm. You might be thinking, but how can we possibly prove this? The truth is, we can't. Not yet, at least. These are theories that push the boundaries of our current understanding. They challenge us to rethink what we know about the nature of reality and the universe. But isn't that the beauty of science? It's a never-ending quest for knowledge, a journey that takes us to the edges of our understanding and beyond. Quantum jumping is just one piece of this cosmic puzzle, a stepping stone towards the possibility of a multiverse. Quantum jumping thus challenges our understanding of reality and nudges us towards the concept of a multiverse. Quantum jumping is indeed a mind-blowing concept. It's a principle that seems almost fantastical, but it's rooted in the solid, albeit somewhat surreal science of quantum physics. This is not the stuff of science fiction, but rather the fascinating world of quantum mechanics. Let's take a moment to revisit our journey. We started by understanding that quantum jumping is a transition between quantum states. Just as a particle can exist in multiple states at once, this theory suggests that we too could potentially exist in multiple realities simultaneously. It's a dazzling concept, and one that truly pushes the boundaries of our understanding. Then we delved into the implications of quantum jumping in everyday life. We discussed how it could potentially explain the strange occurrences and hunches we sometimes experience. It's a tantalizing thought, isn't it? That our gut feelings or déjà vu moments could be glimpses into alternate realities. We also explored the connection between quantum jumping and the multiverse theory. We pondered over the possibility that each quantum jump could potentially be a leap into an entirely different universe. It's a concept that boggles the mind, but also one that opens up a universe of possibilities, quite literally. Throughout this journey, we've ventured into the realm of the quantum, a realm that is as fascinating as it is mysterious. We've peeked into the world of the tiny and the tremendous, a world that seems to defy logic, and yet is the very fabric of our existence. Quantum jumping truly opens up a world of possibilities. It's a concept that invites us to question, to wonder, and to explore. It encourages us to push the boundaries of our understanding and to venture into the unknown. And in doing so, it enriches our lives with a sense of wonder and curiosity. If this journey into the quantum realm has sparked your curiosity, if it has intrigued you or made you wonder, then you've already taken the first step towards understanding the fascinating world of quantum mechanics. And we invite you to continue this journey with us. If you enjoyed this exploration of quantum jumping, please comment, like, and subscribe to Embark True North.